Jane children, welcome back to the chemistry class. Continuation of the 13th chapter, amines. Here we discussed about the physical properties of amines. The lower aliphatic amines are gases with fishy odor. Primary amines with 3 or more carbon atoms are liquid and higher ones are solid. But aryl amines are usually colorless but get colored on storage due to the atmospheric oxidation. Next, solubility. Lower aliphatic amines are soluble in water due to the formation of intermolecular hydrogen bonds with water. But higher members are insoluble in water due to increase in size of the hydrophobic alkyl part. Aliphatic amines are more soluble than aromatic amines. Then tertiary amines insoluble in water due to the lack of hydrogen bonding with water. So the solubility is in the order. Primary amines are more soluble in water compared to secondary amines than compared to tertiary amines. But these amines are soluble in organic solvents like alcohol, ether and benzene. Next, boiling points. Amines have higher boiling point compared to corresponding hydrocarbons due to the formation of intermolecular hydrogen bonding. Boiling points of primary amine is more than that of secondary amines, which is more compared to tertiary amines. The boiling point is more for primary amines because the extent of hydrogen bonding is more in primary amines compared to secondary amines. Amines have higher boiling point compared to hydrocarbons, alkyl halides, ethers, etc. But they have less boiling point compared to alcohols and carboxylic acid. In alcohols and carboxylic acid, extent of hydrogen bonding is more, so they have more boiling point compared to amines. Next, we discussed about the chemical properties of amines. Like ammonia, amines are basic in nature due to the presence of a lone pair of electrons present in the nitrogen atom. This lone pair is donated to the proton of an acid to form a new bond. Generally, they are weak bases because they dissolve in water to produce a less amount of OH minus ions per unit oleum. For example, an alkyl amine RNH2, R is the alkyl group, NH2 is the amino group. Alkyl amine RNH2 combined with water to produce hydroxyl ion is given in the equation. RNH2 plus H2O gives RNH3 plus OH minus. The equilibrium constant K is equal to RNH3 concentration into OH minus concentration divided by RNH2 concentration into concentration of H2O. From this equation, the basicity constant Kb can be written as Kb is equal to concentration of RNH3 plus into concentration of OH minus divided by concentration of RNH2. Here, the concentration of water is taken as a constant. You get an idea of basicity of amines from its Kb or pKb values. The larger the value of Kb or smaller the value of pKb, the stronger is the base. The pKb value of some amines are given in the table. From this, we can identify that the aliphatic amines are more basic than aromatic amines. For example, aliphatic amines such as methenamine, the pKb value is 3.38, and the aromatic amines such as benzenamine or aniline, the pKb value is 9.38. The less pKb value will be more basic. Here, methenamine have less pKb value, so which is more stronger base compared to aniline. The basic strength of amines are affected by the following factors. First one is the inductive effect of groups present in amines. The second one is the ease of solvation of protonated amines. Third one is the steric hindrance. First one is the inductive effect of alkyl group present in alkane amines or alkyl amines. We consider a primary amine. Primary amines means nitrogen is attached to only one alkyl group and two hydrogen atoms. This is a primary amine. So here alkyl groups have plus I effect, means electron releasing effect. So electron releasing effect means R group having a tendency to push electrons towards nitrogen atom. Then the nitrogen, already a lone pair is there. Then alkyl group push two electrons from the bond towards nitrogen atom. Then the nitrogen atom become more rich with electrons. Then for avoiding electron repulsion, the nitrogen easily release the lone pair of electrons. You know, the species which easily release lone pair of electrons are strong base. So here primary amines are more basic than ammonia. But in the case of secondary amines, you can see in the figure, nitrogen is attached to two alkyl group, means two carbon atoms, and one hydrogen atom is there. So this is a secondary amine. So two alkyl groups, so these having plus I effect or positive inductive effect, means electron releasing effect. So these two alkyl groups push the electrons towards the nitrogen atom. You know, already the nitrogen atom a lone pair of electron is present. Then these two bonded pair of electrons are pushes towards nitrogen atom through these alkyl groups. Then the electron density is more in nitrogen atom compared to that of primary amine. So this nitrogen atom, to avoid repulsion, easily release that lone pair of electrons. But in the case of tertiary amines, you can see nitrogen atom is attached to three alkyl groups, means three carbon atoms. Then these three alkyl groups having positive inductive effect or plus I effect, means electron releasing effect. So these three alkyl groups pushes the three bond pair of electrons towards nitrogen atom. Then already in nitrogen a lone pair is present. So to avoid electron repulsion in nitrogen, the nitrogen easily release that lone pair of electron. So compare the primary, secondary, tertiary amines basicity. Then tertiary amines are more basic than secondary than primary amines because of the plus I effect of three alkyl groups in tertiary amines. Therefore, in gaseous phase, the order of basicity is tertiary greater than secondary greater than primary. So, we can conclude that alkyl amines are more basic than ammonia, and from this alkyl amine, the tertiary amines are more basic than secondary than primary amines.